When you start Autograph, it looks like this. Let's just get rid of this bit here. So right click on it and get rid of Show Key. Okay, go to the axes, okay, and set the X from -3 to 3, and set the Y from -8 to 8. Go to this one here which says Appearance. This one here which says Appearance, and select the preset theme here and go for graph paper. Let's just change some of the colours. We're changing some of the colours here. We'll change the axis back to black, and we'll make the grid like grey like IGCSE, and make the white background white, and press OK. Right, it doesn't quite look like graph paper yet, so what we need to do is go back to axes, which is this one here, okay, and change the pips here on the x-axis to 0.2. And you can see now you've got nice looking graph paper. Just so that we can make the axis a little bit bigger, go to Appearance again and edit the font for the axis numbers and make it a bit larger so we can actually see it. I'll go for 16, that'll probably make it a bit larger so we can see them a bit better. Okay, so we're going to draw a graph. So we need to draw a graph, we need to go to this one here. Okay, and the graph I want you to draw is y is equal to 2x cubed, so this one here for cubed, plus x squared. Now, a little trick with Autograph with x squared, if you press x twice, it will do x squared. Doesn't work for x cubed, unfortunately. Minus 4x minus 3. And press OK. Okay, and to label it, click it, and go to a text box, which is here. Okay, get rid of the bit that says equation 1. Okay, and we've got the thing like that, and just click it so it appears red here. Right, the problem is we want to find the gradient. Now the gradient all the way across this curve changes. Okay. Now what you have to do in IGCSE, you're normally given a point, so go to point mode, which is there, and anywhere somewhere down here just attach a point to the curve. Okay, and then go back to select mode, which is the one at the top. Okay, with that point selected, go to Object, and you will find one here that says Tangent. Select it, and we've got the what's known as the equation of the tangent. Now, if you click this, disconnect everything, and then just click the blue line, and then go to text box. It will give you the equation of the tangent of the line. Okay, and what you have to do come up in IGCSE sometimes is to come up with the value of the gradient, which gives the value of the gradient of the curve at that particular point. Okay, let's also do this as well. Click this point here and go to text point, and rather than use point, use P and press OK. And we've got the point here. Okay, let's move it up a little bit. It's been a bit stubborn. Oh, it's locked to the point. So to unlock it from the point, click this one here, click the point in the text box, and deselect anchor to point. Okay, now you should be able to move it up here underneath the tangent. Okay, so what we're saying is the gradient at this particular point here is, using y is equal to mx plus c, is 14.7, and the point has coordinates minus 1.94 minus 6.079. Okay, and if we select that point and move it, the tangent will move, and you'll see the gradient changing. So here the gradient is positive. Here it's a very interesting point at this point here, because here, so just go back a bit difficult. It's very small. In fact, it's actually equal to 0 at that particular point. Okay, and then if we go down this way, the gradient is negative. Okay, at this particular point, somewhere down here, the gradient, the tangent passes from one side of the curve to the other. That's called a point of inflection. We'll look at that later. Okay, and then this particular point down here is obviously of interest because here the gradient will be equal to 0. So you see, when the curve has a maximum or local maximum or local minimum, the gradient of the curve will be equal to 0. Okay, and we move up here. So the tangent gives us the gradient of the curve at any particular point. Okay, and then the secret would be to find, come up with a way of coming up with the formula for that particular curve. Later you will do a problem where you have to find the equation of the tangent at that particular point. 1 minus 4. Okay, so that's what the definition of a gradient is using autograph.